All right, hey, let's talk some more about equivalence classes. So this is 4.25C. Describe the equivalence class of the relation, the equivalence relation between x and y, where x is equivalent to y if and only if x mod 4 equals y mod 4 and x mod 6 equals y mod 6. All right. So I'm going to break it down, hopefully try to make this a little bit more simple. The first thing to understand is just this notation here. So this, if you have something like this inside the square brackets, that represents the whole equivalence class for that element A. So it is the set of all the x's where x is equivalent to A. So it's pretty simple. It's just a way to say all the stuff that equals A, given our equivalence relation. So remember, we can kind of conceptualize equivalence classes this way. We just have a set of elements, and we sort of break them up into groups, and then we say all the things in the same group are equivalent to each other. So B is equivalent to D, because they're in the same equivalence class. But if we look at some of a little bit more simple version of the math, or simpler version of the problem, I guess you could say. So let's just go through this. Say the equivalence relation between x and y, where x is equivalent to y, if and only if x mod 2 equals y mod 2. So we can see that this will have two equivalence classes, two groups of things that are equivalent to each other, and that's going to be all of the even numbers and all of the odd numbers, right? Because if you take any two even numbers, then your first one, your x mod 2, is going to equal 0. And your second one, your y mod 2, is also going to equal 0. Sorry about that. And the same is true for all of the odd numbers. So we have two equivalence classes, the 0 and the 1 equivalence class. And we could say more generally that for 0 and 1, the formula, a definition for the equivalence class of n is 2k plus n for every natural number k. Right? So if we just plug in 0 for n here, we get all the even numbers. If we plug in 1, we get all the odd numbers. Right? So we can just think of that as drawing, all the even numbers on one side and all the odd numbers on the other, and just a line between them. So then we have an equivalence class of even, and the other one is the odd numbers. But how do we sort of put these two things together, the and, right? So if x mod 4 equals y mod 4 and x mod 6 equals y mod 6. Well, it's a little bit easier if we just look at the table of values here. So in this case, an x is equivalent to y if if you take the x and the y and you take the mod 4 and the mod 6 of the x, and those values equal the mod 4 and the mod 6 of the y. So this is our table of all the possible pairs of mod 4 and mod 6 that you can get. And if you look at it, you'll see we'll repeat once we get to 12. And yeah, that's pretty much the idea there. So what we're looking for is actually the smallest number that divides both A and B, both 4 and 6. So that is 12, right? There's no number smaller than 12 that evenly divides both 4 and 6. So 12 is kind of our magic number there. And it'll make a little bit more sense when we look at the answer here, hopefully. So this is in the black, the correct answer from the textbook. There are 12 classes, 0 to 11, where you can sort of build the equivalence class of n using the formula. The equivalence class of n is equal to 12k plus n for every natural number k. So we can sort of see that, like, let's take the equivalence class of 4 as an example. So 4 mod 4 equals 0, and 4 mod 6 equals 4. But then if we look at 16, 16 mod 4 equals 0, so the mod 4 of both equals 0, and the mod 6 of both equals 4. 16 mod 6 equals 4. So we can see that both 4 and 6 are in the equivalence class of 4. Cool.